Hello and welcome to this solution video. If you are going to like this video, please share with your friends, give it a thumbs up and subscribe to Math United. That will motivate me to make many more videos in future too. Only 8% of my subscribers watch videos of mine and 92% are not subscribed at all. So if you subscribe, that will be very motivating. Let's start with question number 1. Becky sometimes works in an office and sometimes works at home. The random variable x denotes the number of days she works at home. Okay, this at home. So it is given that p probability of x is equal to x is k this where k is a constant and x is 1 2 3 4 only 1 2 3 4. Okay, draw up the probability distribution table for x, giving the probabilities as numerical fractions. So there are just 4 options, so we will start with only 4. 1 2 3 and 4. Now we will write here x, x is this one, and then probability of x equal to x is equal to kx x plus 1. So let's write here p x is equal to 1 will be k x x plus 1. So in place of x I replaced 1 because that is my x. So probability of x equal to 1 is equal to 1 times 2k. So I will write here 2k. Same thing I will do with 2 now. In place of this 1 and this 1 I will write 2 now. So probability that x is equal to 2 is k 2 plus 1. So 2 times 3 6k. So I hope you understand, it is the number plus one number multiplied, like this. 3 times 4 will be 12k. 4 times 5 20k. But they said the probability should be numerical fractions and we have not gotten that yet. What we know that the sum of all the probabilities, because they said only these 4 are the possibilities, their sum will be 1. So 2k plus 6k plus 12k plus 20k is equal to 1. And let's see how much is this. 2 plus 6 is 8 plus 12 20 plus 20 40. So k comes out to be 1 out of 40. So now let me write the actual probabilities replacing these 2k. So these are the real probabilities which I'm going to write in next row. So 2 times 1 over 40 will be 1 over 20. This is the numerical fraction. 2 multiplied by 1 over 40. 6 times 1 over 40 will be 3 over 20. 12 times 1 over 40 will be 3 over 10. And 20 over 40 will be half. 20 times 140, half. So this is our probability of x is equal to x. You can remove this case now and just leave these fractions. Their sum will definitely be equal to 1. Okay. Next part, find the expected value of x and variance of x. Okay, so expected value, let's start it here. The formula for expected value is sigma x probability of x. It is divided by sigma p also, but we know the sigma of probabilities is 1. If I add all of them is 1, so there is no need to write denominator. So this is what we'll do. We'll multiply x and px first and then sigma means add them. So let me start here. X is 1, its probability is 1 over 20. So 1 multiplied by 1 over 20. plus 2 times 3 over 20, which is, okay, I will write here 3 over 20. Then 3 times 3 over 10 plus 4 times half. Okay, since the denominators are different, I will try to make that denominators the same. First, let me multiply 1 times 1 over 20, 1 over 20 plus 6 over 20. Only numerator multiplies, that you may not know. That you may know. Sorry. 9 over 10. So I can multiply this by 2 here and 2 here, so to make it 20. So it becomes 9 times 2, 18 over 20. Then plus, this will be, let me make it 10, multiply here by 10, multiply here by 10. Well, that's so that it denominator becomes 20. So 4 times 1, 4 and 4 times 10, 40 over 20. So that will be how much? 7 plus 18, 25 plus 40, 65 over 20. And if I divide, it will be 3.25. 65 divided by 20. Yeah, 32.5 divided by 10. So yeah, 3.25 will be the expected value of X. What it means? That she will go work from home. Yeah, she works from home. So she works from home on 3.25 days. That is the mean, kind of. Now variance. The formula for variance is sigma again, but this time it will be x square probability minus expected value, its square. So expected value we already know, so we'll use just this one later here. I'll focus on this one first. So here I have to square the probability first. This one I did not square, I just wrote 1. Now I will square it. Probability is 1 over 20 plus 2 square 3 over 20 plus 3 square 3 over 10 plus 4 square times 1 over 2 and minus expected value is 3.25 square. Okay, so this gives me 1 over 20 again plus 4 times 3, 12 over 20, and again I will multiply by 2 so that the denominator becomes 20. So 9 times 3, 27 times 2, 54 out of 20 plus, I'll multiply this by 10, so it becomes 16 times 10, 160 divided by 20 minus 3.25 square. So 1 plus 12 is 13 plus 54, 67 plus 162, 27 over 20 minus 3.25 square. This will be 11.35 minus 3.25 square. So let me see how much this gives me. Let me use my calculator. By the time I'm doing this, I would request you to like this video, share with your friends, and subscribe to Math United. So it will be 0.788. This is 7875. So rounded off to 3 significant figures. This is our variance. Question 2. The weights of large bags of pasta produced by a company are normally distributed with a mean of 1.5 kg. So 1.5 kg is the mean. 1.5 kg. And standard deviation is 0.05. Done. The probability that a randomly chosen large bag of pasta weighs between 1.42 and 1.52 kg. What is the probability of that? 1.42 will be below this and 1.52 will be above this. So they're saying that this is the probability we have to find out. So my plan will be to find the probability of this area which is below 1.52, this area. Then I'll find the area below 1.42, this dotted part. Now from the bigger one, I'll subtract the smaller one and I'll be left with this shaded part. That is the plan. So I'll find the Z scores for both of them first. So Z score for X is less than 1.52 will be the X value, which is 1.52 in this case, the upper value, minus mean, which is 1.5, divided by the standard deviation, which is 0.05. Similarly, I'll find Z score for X is less than 1.42, which is part of my plan, right? For the smaller area, which will be 1.42 minus 1.5 divided by 0.05. So this one comes out to be 0.02 over 0.05, which will be 0.4, right? Yes, 0.4, because both are two different places. Here, it will be minus 0.8 rather, over 0.05, that comes out to be minus 1.6. Okay, this negative will take care later. Let's look at the 0.4 first by old-fashioned table. Here it is, the table. 0.4 I have to look for. Z score is 0.4. The probability will be 0.6554. It will be 6554. So probability that X is less than 1.52 is 6554. Now here, the probability that X is less than 1.52. If it was positive 1.6, it would be easy, right? But there is no negative here. So in that case, what will we do? We will just write 1 minus in that case. That means we are reflecting. We are actually finding this area, this one. And since this normal distribution curve is uniform, whatever is this area is the same area. 1.6. So 1.6 is 0.9452. So we need to write here 0.9452. Okay, which will be equal to 0.05. Okay, so we got the probability for both. Now we have to subtract this from this one. So probability that the X is between 1.42 and 1.52 is 0.6554 minus 0.0548 will be, so 0.6554 minus 0.0548 will be 0.6006. 0.6006, so I'll write 0.601 because 06 will make it 1 to 3 significant figures. This is the probability of the bag being between 1.42 and 1.52 kilograms. Okay, the weights of small bags, pasta produced by the company, are normally distributed. That means it's a different set of bags and they are smaller in size. So their mean is 0.75 kg and standard deviation is unknown, which is sigma, and it is found that 68% of these small bags have weight less than 0.9. So they have given the probability 0.68, and let me write 0.9 here. So less than, right? Small bags have less than 0. So our job is very easy now, because our table gives us always less than, not more than. So we have this. So we have to convert the probability they have given is that, oh, let's use a different variable. Y is less than 0.9 is 0.68. Now we have to convert it to Z score of y being less than 0.9. So we have to convert this probability into Z score, and it will be here 0.68. 0.6772. This is the one. So this gives us two digits, 0.4 and 6. Now make this 72 a complete 6, so that this becomes 6800. We need 28, and 28 will be, it's 29 here, so we can take 8 because it's closer to 29, not 25. So we'll take 8 as the third digit. 0.468 is the Z score. Okay, 0.468, and Z score is what? The Y value, which is 0.9 for this case, minus average mean 0.75 divided by the standard deviation, which is unknown. So we will use this part to find our sigma, and this sigma and 468 can interchange their places by cross multiplication. So sigma comes out to be 0.9 minus 0.75 over 0.468, which is 0.15 divided by 0.468. So let's see how much is this. I'm calculating. By the time I'm doing this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 25 over 78, or 0.32051, 0.3205. So I need 3 significant figures. I'll make it 1. 0.321 is the standard deviation in this case. Question number 3. Tim has 2 bags of marbles, A and B. So let me draw those bags. So this is one bag. This is second bag. Bag A has 8 white, 4 red, and 3 yellow marbles. Bag B, this is A, this is B, has 6 white, 7 red, and 2 yellow. Okay. Tim also has an ordinary fair 6-sided dice. He rolls the dice. If he obtains a 1 or 2, he chooses 2 marbles at random from bag A here. So 1 or 2, you choose this one. And if he obtains, without replacement they said, from bag A. If he obtains a 3, 4, 5 or 6, 3, 4, 5 or 6, obviously he will choose bag B. And this is also without replacement, and also 2 marbles. Same situation, but probability will be different. Find the probability that both marbles are white. Okay, so for getting this white, first we should get 1 or 2. So if bag A, if that white is from bag A, so the probability will be, first we should have these 1 or 2, which is 2 numbers out of total of 6 numbers in die. Then we should have a white here. So 8 out of total, how many are they? 12 plus 3, 15. And there is a second selection also. And because this is without replacement, this out of 8 white, because the first one we have confirmed that it is white, its probability is 8 over 15. The second will be 7 out of 14. Or bag B will be selected. What is the probability that bag B will be selected? there are 4 numbers which will choose bag B. So 4 out of 6. Probability of white is 6 out of 13 plus 2, 15. 6 out of 15. And again, this is for the first one. Second white will be 5 out of 14 because one white is out and it is not replaced. Okay, so 90 times 14, 1260. So this will be 16 times 7. Okay. What about this? Again, 1260 will be the denominator, 90. Okay. 24 times 120. Since either this will happen or this will happen, they are mutually exclusive, their probabilities will add up. So what is the probability that we'll get a white one? Will be 112 over 1260 plus 120 over 1260. That becomes 232 over 1260. 232 over 1260. That is 50 over 315. 58 over 315, or in decimal it will be 0.18412. So I can write 0.184. That's the probability of getting both white marbles. Okay. Find the probability that the two marbles come from the bag B given that one is white, one is red. So one is white, one is red. What is let's call it event A. No, event B, because this is given, right? So we, to make it easy, we'll write it as event B. So event A, what will be event A then? Event A will be the two marbles come from bag B. Two marbles are from bag B. That's event A. So we need to find the probability of A given probability event B. The formula for us is probability of A intersection B divided by probability of B. So let's focus on probability of B first. Here, probability that one is white and one is red. So again, there will be two cases. So bag A plus bag B, whatever comes from these bags. So bag A, what is the probability? First of all, the selection of bag B is 2 out of 6. Now there will be two cases. Either the first one will be white, second will be red, or first one will be red and second will be white. That's possible, right? So what is the probability the first one is white? We already found that from bag A was this 8 over 15. And what will be the probability, because it's without replacement, what will be the probability that the second one will be red? 4 out of 14. Remaining are 14 now. So 8 out of 15 and 4 out of 14. 8 out of 15. Let me make some space. Times 4 out of 14. That's 1. One is white, one is red. But it's also possible the first one is white, 4 out of 15, and second one is white. White, red, red, white. And same thing we'll do here. The selection of bag B was 4 out of 6 multiplied by the probability of white and red. White was 6 out of 15, 6 out of 15, and red was 7 out of 14 in second selection without replacement. So 6 out of 15 times 7 out of 14, or red will be first, so 7 out of 15 times 6 out of 14. Okay, and this will give us the probability of B. Let's see, 2 times 6. Okay, times 8 times 4 is 32, and 4 times 8 is also 32. So we'll add them, 32 plus 32, 64 and 210. 14 times 15 is 210. Yeah, 70 plus 40. Yeah. This is the probability of the first one. I should write equal to here. Plus, this plus 4 out of 6. And this will be 6 times 7, 42, plus 42, 84 over 210 again. So their denominators are again 1260. And we have 128 plus 1, how much? 336, 464. We'll simplify this later. Okay, that's the probability of B. Now we have to see the situation when one is red, one is white, and it is from bag B, this part. So our answer here will be, denominator will be 464 over 1260, and numerator will be this one, 4 over 6. 4 times 84 will be 336, right? Over 1260, we can cancel this, and let's see what is 336 divided by 464. 20 over 20, 21 over 29, or 724. So 21 over 29, or 0.724. Question 4. The weights x kg of 120 students in a sports college are recorded. The results are summarized in the following table. Okay, this is the table. Draw a cumulative frequency graph, which should not be a problem. So 120 is the maximum cumulative frequency. So we will write our cumulative frequency here and weights here. So let me shift it a little upwards. Yeah. Okay. Now, since they have already given the upper limit, 40 is the upper limit. All the data below 40 is 0. That means 40 is the upper limit. At 40, we have 0. So we can just mark it here. Similarly, less than 60, that means upper limit is 60, we have 14. So 60 and 14. So that's how we will just point out here. So 6. Okay, it will be somewhat like this. And draw a cumulative frequency graph to represent this information. We have done that. What is next? It is found that 35% of the students weigh more than WKG. More. This is all very common kind of question. 35%, upper 35%, more than WKG. So if W is here, somewhere here, maybe 70, this is more, right? So that means the corresponding frequency, cumulative frequency, will be above something. So they said 35% of the students, that is upper 35%, right? So what is 35%, or let me write 65%, lower 65%, it will be easy to see, because scale cannot be from up, can be from down, and from down I will take 65%, not 35%, because 100 minus 35 is 65%, and my scale starts from 0, so I'll go up here. What is 65% of, how many are they? 120, right? 120. So this will be 5, 6, 1, 13, 78. So 65% of 120 is 78. So we will go to 78 here. This is 78. And above this are way more than WKG. Let's see what corresponding number is with 78%. If this is our number here, and we come down here, or somewhere in between here. So 1, 2, 3, and between 2 and 3. So 75. We can say 75 kilograms. So you can say 75 kilograms, sorry, 35%. 35% of the students weigh 75 kilograms and more. Alright. C part. Calculate estimates for the mean and standard deviation of the weights of 120 students, and that needs a lot of work. So I'll have to copy this table first and then we'll proceed. So this is the table, and that is going to help us to find mean and standard deviation, and we'll need to completely change this table. For mean, we'll draw a vertical table where we will write x is less than 40. Yeah, this one. For that, I will write 0 to 40. So first column will be 0 to 40, first data, then it will be 40 to 60, then 60 to 65, then 65 to 70, 70 to 85, and then 85 to 100. Now the frequency given to us is cumulative, so we have to break that down. 0 to 40 are 0 confirmed, so we'll write 0 here. So this is, what do I write here? The class. This is frequency, not cumulative frequency, frequency. So less than 60 are 14, that means all of them are between 40 and 60, because below 40 they were 0. So we'll add 14 here. This below 65 are 38, but that includes 14. We have to remove these 14. So we'll be left with 38 minus 14, 24. In these 60, these two are there, 38, not these two. 38, all of them are there, so we'll be left with how much? 22. Basically, I'm subtracting the previous one from the next one. So I'll subtract 60 from 106, which is 46. 120 minus 106 is 14. Alright, we got our frequency. We know that the sigma f, the total of frequencies, is 120. Now we need, for a mean, we need sigma fx over sigma f. Sigma f is with us. Fx, for sigma fx, we need fx first. So there should be x, because we don't have any x. There is no number which is out of these numbers. We have to select a number which represents the whole class. So that will be the mean of the two ends of the class. So I will add 0 and 40 and divide by 2. That will give me the x, the mid value of these. So 0 plus 40 is 40, divided by 2 is 20. Similarly here, I'll do it. 100 divided by 2 is 50. 125 divided by 2 is 62.5. This will be 135. So 67.5. 155, 77.5, 185, 92.5. I got them. Now next step is to find fx, and fx will be the multiplication of these two, f and x. 0 times 20, 0. 14 times 5, 70, so 700 here. Times 4, 125 times 0, which comes out to be 8545. So now our mean will be 8545 divided by 120, which is 8545 divided by 120. 71.208, so 71.2 is what we will stop with. What is the second part? Not only mean, we have to find standard deviation also. And we should know the standard deviation formula. Standard deviation is square root sigma x square f over sigma f minus mean whatever we got square, and we got 71.2. We'll straight away write 71.2 here, but sigma f is also with us. This is not, so I will have to move it a little bit so that I can add columns to this particular data. So it's here. So I will add one column again so that I get x square now. So I will square x's, these all of them, and then multiply with frequency each one of them, and that's how same thing I will repeat, but with x square, not with x. So let me fasten this video so that it can be done faster. Okay, so it comes out to be sigma x square f is 62506.2.5. So I will substitute it here. 62506.2.5 over 120 minus 71.2 square. I'll just put this in my calculator and get the answer. By the time I'm doing this, I would request you to kindly like this video, share with your friends, and subscribe to Math United. Only 8% of the people are subscribed to my channel, which is not motivating enough. So please subscribe to Math United. What I'm getting here is 11.8 almost. Question 5. The probability that a driver passes an advanced driving test is 0.3 on any given attempt. A driver means any driver. Deepak keeps taking the test until he passes. The random variable x denotes the number of attempts required for Deepak to pass. That means he will fail, 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 and pass. Whenever he passes, he stops. So how many failures are that before that is the question here, and the attempts they are saying is find p that x is from 2 to 6. 2, 3, 4, 5, and 6. There are equal signs here. Can you see? That means he either gets success in second, third, fourth, fifth, and sixth. That means for sure he is getting any one of these attempts, he is getting success. In other words, he is not failing in these. So let me add 1 also, which is missing in this list. There can't be 0, right? Because without giving a test, how can he pass? So 0 is not a possibility. 1 is the one which they have excluded. So what will I do? I will include 1 also and then subtract the probability x is equal to 1 from this. Okay. So 1, 2, 3, 4, 5, 6. It is sure that he got success in one of these attempts. That means we are sure that he did not fail in all 6 attempts. And Q is the probability of failure. Probability of success is 0.3. Probability of failure, Q, is 1 minus 0.3, which is 0.7. So probability that he gets success in 6th attempt or below, including 1, is this, which is 1 minus 0.7 to the power 6. However, 1 we want to exclude, and the probability of success in the first attempt is 0.3. We'll subtract that case because we don't want 1 to be there. So 1 minus, we'll do this one first and then we'll subtract this. So 1 minus 0.7 to the power 6 is 0.882351, and we will subtract 0.3 from it, so we'll get 0.58231. so we'll stop here, 0.582. Okay, so now we have to write what is the expected number of attempts he will get a success on. So for expected value, we know it is 1 over q, and 1 over q. One over p, which is 1 over 0.3 or 10 over 3. Okay, next question please. 5 friends will each take their advanced driving test tomorrow. Find the probability that at least 3 of them will pass tomorrow. So 5 are taking at least 3. So probability that x is, let's write y this time again because this is binomial now. So y is at least 3 of them greater than or equal to 3. So it is equal to probability y equal to 3, or 4 of them pass, or all 5 of them pass. Alright, so out of 5, so using binomial probability, we will write 5C3. 3 of them are passing. The probability of passing is 0.3 to the power 5. Same, not 5, 3. 3 of them are passing, right? This number and this number must match. Remaining out of 5 will be failing. So 0.7 to the power 2. So this ensures, 5C3 ensures that any one of them can pass, and any 3 of them will pass, any 2 of them will fail, and this is the combination it ensures. Then we have next one, 5C4 pass, so 0.3 to the power 4 and 0.7. Then we have 5C5, 0.3, all of them pass and no one fails. Just put this in a calculator, you'll get it. I will do it myself. So it comes out to be 0.16308. So I'll stop at 0.163. C part, 75 people will take their advanced driving test next week. Use the approximation to find the probability that more than 20 out of 75 of them will pass. Okay, so since the number is too big, we will have to use normal approximation for this. For that, first we will see if NP is greater than 5 or not, NQ is greater than 5 or not. So 75 is N and P is 0.3. So it will be more than 25, right? Yeah, it is more than 25. So definitely it is going to be more than 5, and 75 and 0.7 NQ is also going to be greater than 5. So we can use normal approximation for this. So let's find NP, which will be the mean. Okay, it will be 75 times 0.3, which is 22.5. Yeah, okay, and then we will write the standard deviation, which will be square root NPQ, and that is going to be NP is already known to us, 22.5. Q will multiply and then find square root of that. So let me see this, 22.5 times 0.7 of square root 3.9686. okay, so what can I write it? 3.97. let me write 3.97. now our mean comes out to be 22.5, and we want more than 20. So that means 20 should not be part of it. 21 should it start with 21, because we have approximation here. So to exclude 20, we will write 20.5 as the number here, and we want more than 20.5, which includes 21, and automatically it makes it 20, more than 20. So we have to find Z score for X is less than 20.5, because our table, the table we are going to use is less for less than, but surely it is going to be negative. So we will use its reflection. Suppose this is whatever Z score it has here, same distance, this will be the Z score. And if I subtract the positive part of it from 1, that actually will be the one which is more than this. I hope you understand. The reflection of this part, or this part, will be the part we want exactly. So I'll just convert whatever Z score I get here in negative. I'll just look for positive in the table and I'll get it. First, let me fetch the table. And I have the table now. So I'll find the Z score first. 20.5 minus 22.5 divided by 3.97 comes out to be minus 0.5037. So let me go to 4 and see 0.504. What is negative? I'm ignoring for the reason I already explained to you. So 0.504, 0.50, this is 69, 0.6915, and 4 is 14, in the same line 14. So it will be 0.6929. Yeah, that's the one. So our probability that X is greater than 20.5, not less than anymore, is equal to 0.693, we can say 6929 can be rounded off to 693. Question number 6. Jay and his wife Kaz are having a party. Jay has invited 5 friends and each friend will bring his wife. That means 10 people are coming, right? 5 times 2, 10. At the beginning of the party, the 12 people, Jay, Kaz, and those 10 invitees, will stand in a line for a photograph. For how many different arrangements are there of the 12 people if Jay stand next to Kaz and each friend stands to his own wife? Okay. So basically, there will be how many pairs? 6 pairs. Right? Each pair will have two people inside. That means they can change 2 factorial ways, they can change 2 factorial ways, 2 factorial and 2 factorial. That means all of them 2 factorial. That means 2 factorial to the power 6 ways they can change within these boxes, right? And then these 6 boxes can change places with each other in 6 factorial ways. So this will ensure that the husband and wife are together in all 6 cases, but they can change their place with each other. And this is what it will be. Let me use my calculator for this. 2 to the power 2, yeah, 2 to the power 6, 64 times 6 factorial. It comes out to 46080. That is the number of arrangements. Okay. How many different arrangements are there of the 12 people if J and Kaz occupy 2 middle positions? Okay, so J and Kaz are in middle position, but they can change their place again. Yeah, they will still be in middle. Okay, and 5 wives. J's 5 friends on one side, so male, 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 and male, and wives are on other side. 1, 2, 3, 4, 5. So 2 factorial ways they can stand here. These can stand 5 factorial ways, and they can also 5 factorial ways. And it's also possible. Are they saying left and right on one side and on the other side? That means they can also change their places. Females can be here and males can be here. So that is also again 2 factorial ways. So it becomes 2 times How much is this? 120 times 120 times 2. 4. 144 times 4 will be 576.00. These are the total number of ways they can stand. Alright. For a competition during the party, 12 people are divided at random into group of 5, a group of 4 and a group of 3. Okay, find the probability that Jay and Kaz are in the same group as each other. Okay, so first we will do what? There will be 3 cases. So group of 5 first, then group of 4 and group of 3. So we'll see first case is that they are in group of 5. The Jay and Kaz, they are in group of 5. So they are fixed here. We need 3 friends now, and others are not, they've not given any condition for others. Okay, that means in this group of 5, we need just 3 people now out of remaining, how many? 12 are they? So 10. Out of 10, we will give 3 to this group of 5. Then remaining, how many people are left? Out of 12, 5 people are in this group, so 7 are left. 7 C, and we need 4 in the second group, and then it will be left with 3C3. So here J and Kaz are in group of 5. Now J and Kaz are in group of 4 now. So we'll select 4 on first. So out of 10 remaining, we need 2 for J and Kaz's group. So that makes it 4. Remaining people are now 8. Yeah. And we have to select group of 5 out of them, and then there will be 3C3. So 2 plus 5, 7 plus 3, 10, and 2 are already fixed. Now J and Kaz are in group of 3. So we need just one person out of remaining. Were they 10 here? Yeah, 10. 10C1. We need just one person to make group of 3 because J and Kaz are already in this group. Then remaining are how many people? 3 are gone here, so 9. C will make a group of 5 first, and then we'll make a group of 4. So either this case will happen, or this case will happen, or this case will happen. We will just find them separately, and that will give us no more number of combinations. But they're asking probability. We'll take care of probability first. First, let me evaluate this. So this one first. I will just write them one by one. Now, the total number of groups which can be done, prepared will be written here. So total, let me write here total. Now, J and Kaz are not in specific groups. We'll see. First, we will select out of 12 a group of 5. Then remaining 7 people will take a group of 4, and then remaining 3 will be in the remaining group. Right? So this is what will be the denominator of this one, which is 27720. And now we will find all of this. By the time I'm doing this, I would request you to please like this video, share with your friends, and subscribe to Math United. What I'm getting here is 19 out of 66. In decimal, it will be 0.288. 2.8287878 is coming out, so I write 0.288. And this concludes our solution video of this exam paper. I hope you liked it. If you did, please give this video a thumbs up, spread it among your friends by sharing, and subscribe to Math United. If you do that, it will motivate me to make many more videos in future too. Thank you very much.